This is a 1968 Holbrook Minor lathe that I've converted to CNC. The Minor wasn't far off CNC for its time anyway, because it had infinitely variable spindle speed and infinitely variable feed speed, all handled down here from a panel a bit like this one, except made of 1/4 inch thick brass, because it was 1968. Actually, that doesn't make sense. Even in 1968, 1/4 inch thick brass was pretty silly. Anyway, so amongst the things I've done, I replaced the threading chart with the keyboard. I've replaced the feeds gearbox here with a brand new casting, which contains a servo motor and a piece of wood. There's another casting to be made to go on the front of here with a nice Holbrook logo, but for the time being it's just like that. The control panel here has pretty much the same controls as the original one. We have one knob for spindle override, one knob for feed override, some switches to control coolant and the operation of the brake and the spindle speed range. Except now instead of having on-off for these things, I have on-off and auto. So they can either be controlled manually or they can be controlled by Linux CNC. This is currently the touchy interface, which may be what I use or may not be what I use. I'm not sure yet. I also removed the compound slide, get rid of that, because that's really irrelevant for a CNC lathe, and I've replaced it with a solid block of metal and a multi-fix tool post. Well, I'll say multi-fix. It's a Chinese version of multi-fix, which is much more affordable by the likes of me. There is a bicycle in the background, don't worry about that. The lathe's pulled away from the wall so I can get to the back of it to access the drivetrain. And as you'll hear later, the drivetrain needs access because it's got a bit of a noisy bearing in it. Now I'm pretty sure that it's in the gearbox and not the spindle. Which actually you might think will be good news, but it's bad news because the gearbox bearings are more expensive than the spindle bearings. I have no idea why. Also replaced was the lead screw and power shafts. They've gone. You see on this side I have a nice spring cover on the lead screw, and this side I don't yet. And also missing from here is another bearing. There should be an outrigger bearing here to hold another lead screw cover. But I'm not there yet. I just couldn't wait to get this thing going. I've also completely replaced the apron casting. So this now contains a servo motor and two knobs for X and Y feed. I've also added a little, well, recreated the oil pump. So there's an oil sump in here which pumps oil to all the various movements in the apron and to the lead screw. There's a separate pump in the back of the headstock here, which you can't see, which pumps oil to the head bearings and to the drive chain for this servo motor. Yep, I said drive chain. I have, in fact, the whole machine is driven by chains running in oil. I like belts. Belts work well. I just wanted to try something different. I might go to belts in the end. I'm not sure. The chains are actually silent chains from motorcycle cam chains, which are a similar zero backlash kind of timing application, so it ought to work well. We'll find out in about 20 years, no doubt. As I don't really expect them to wear out quickly, so if there's anything wrong, it'll either show up very soon or never. I have reproduced the control layout of the original lathe to a large extent. So on the control panel here we have feed. You can't see that in the light's terrible, isn't it? Feed and spindle speed override, or spindle speed, and here we have two knobs which I am going to try to twiddle and at the same time show what's happening. I'm not sure I can. So I have to go jogging here, and as I turn this knob, the lathe moves, and this is X, or cross slide as it would be called were it not CNC. And now, in a fit of excitement, I'm actually going to press go on a CNC program. Now this is quite exciting because I genuinely have not yet run this lathe with metal in the chuck in CNC mode, so it's anybody's guess what's about to happen. So here's the program. It's a sample program that comes with Linux CNC called Pawn, and should make a pawn. That's with a W. This being the internet, I should make that clear. Right, so let's try it. Clearly that wasn't exactly right, because I think I have a problem with radius diameter mode. Let's fix that. So, take two. I've decided, I've sorted out the problem with the diameter radius thing. I'd actually touched off to the radius mode with the diameter reading, so it's all my fault. I worked out that the stock should be 25mm diameter rather than what it was, and also that it should be a different tool geometry. And now, take two.